All right, Chapter 6 tests, Part 1, Day 1. Here we go. Let's get after it. So the first problem is a subtraction problem. So what you want to do is you want to distribute, over here, it's just a 1. So you can just pretty much drop the parentheses. But on the other side, there's really a negative 1. So I'm going to change the sign of every single term in that second parenthesis. And now that I've changed all the signs, I'm going to just go through and I'm going to gather up like terms, starting with the biggest power first. So I'm going to have a negative 3a to the 4th. And actually, take that back. I have 2 of those. So I'm going to have positive 3a to the 4th. And then I go to the 8 to the thirds. I have 8 of those and 3 of those. So that gives me 11a to the thirds. Then I have negative 7a squareds, and then the positive 3 constant chilling here at the end. There we go. All right, next question, number 2. Sliding down. Since this is plus, you can just ignore all parentheses and just combine like terms as is. So let me see, the biggest one, I have a negative 8x to the third, negative 2. So there's a negative 10. 3x squareds and 2x squareds, a positive 5x squareds. And then I have the constant 6 and 3, which comes out to be a 9. So correct answer for number 2, boom. Moving on down, number 3. So we are multiplying a trinomial times a trinomial. So you could use boxes, or you could just use distributive property. I'll just distributive property because it's a little faster. So let's do this first term times basically all 3 pieces. So when I do that, I'm going to have 25n to the 4th minus 15n to the 3rd plus 15n squared. All right. Now I'm going to come down and I'm going to do the 6n times all 3 pieces. So let's do this part. So that would be 30n squareds, 30n to the thirds. So I like to stack mine up there. Then I have a negative 18n squared. And then I have a positive 18n. And then last row is going to be the 7 times everybody. So 7 times 5n squared. That's 35, not bad, 35n squared. Then we have minus 21n plus 21. Now I got to gather up all of my like terms, kind of go through and make sure I got all my pieces here. So I have 25n to the 4th. That's going to be 15n to the thirds. That's 50 and a negative 18, so that's 32 n squareds. And that'd be minus 3n's and plus 21. So final answer. Let's move on up to number 4. So you could multiply this out 4 times. It's a little faster if you use Pascal's triangle. So I wanted you to learn how to do that. First of all, you got to know Pascal's triangle is like 1, 1, 1. You're adding the 2 numbers in top and between. So you always start off with 1. 1 plus 2 is 3. 2 plus 1 is 3. Finish with a 1. 1, that'd be 4, 6, 4, 1. And since this is a 4th power, I'm going to use this row right here that starts off with a 4 in it. All right. It looks like the 5th row, but you kind of have a row 0 at the top there. So those coefficients are going to kind of lead or dictate what's going on here. So I'm going to just put my 1, my 4, my 6, my 4, and my 1. And here's kind of how the pattern goes. You take the first term, and I'm going to put it in parentheses, so that's a 3y. And I'm going to start with the 4th power, and then I'm going to do it to the 3rd power, and then I do it to the 2nd power, Then I do it to the first power. And I don't need to do it to the 0 power because it's just going to be a 1. So I don't even write it there. Then you go to the next piece, and you go to this negative x term, and you start writing that one, and it's going to build itself up. It's going to start with nothing, and it's going to build up negative x to the first, negative x squared, negative x to the third, and eventually negative x to the fourth. Well, now we got to clean all this up. And remember, when you have a number inside of a parenthesis and you're raising it, you have to raise that number to the power. So that 3y to the fourth is really 3 times 3 times 3 times 3. So that's 81 y to the fourth times 1. All right, which is just 81 y to the fourth. Now the next term, this is really 4 times 3 to the third is 27. That's a y to the third. And then a negative x to the first is just times a negative 1x. So that negative coefficient is going to give me a minus 108 y to the third x. And you can rearrange the x and the y to the third if you want. No big deal. This next one, I'm going to have 6 times 3 squared is 9 y squared. Now, negative x times itself, negative x times negative x, is a positive 1x squared. Becomes positive there. So that's a 54 y squared x squared, or x squared y squared, however you want to write it. I'm just keeping the order the way it is. Well, this is just 4 times 3y times a negative x times a negative x times a negative x. Well, 3 negatives is going to give me a negative 1 x to the third. So those 3 coefficients here, boom, 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 are negative 12 x to the third y, or I could have put yx cubed. And then here at the end, a negative x times itself 4 times. Well, 4 negatives is going to be a positive x to the fourth. So pretty long problem time-wise, but that's what you end up getting when you expand it using Pascal's triangle. Number 5, we have a division problem. Usually I try to use synthetic division, but because there's a 4 there, it just takes a little bit more. You got to end up using fractions, and fractions get kind of messy. So I'm just going to do this one long division. So I'm going to say, all right, 4m plus 1. We need to see how many times that goes into 8m to the third plus 26m squared minus 14m minus 6. And we'll start playing the game. So 4m goes into 8m to the third. That would be 2m squared. Now multiply backwards. So I'm basically always multiplying from this top row back over here. So 2m squared times 4m, that's 8m to the third. And then the 1 is going to give me 2m squared. And then remember, I always subtract here. So I'm going to subtract. So these will cancel out. And I'll end up with 24m squared. Bring the 14m down. If you wanted to, you could bring the negative 6 down right now. You don't have to, but you could. And then 4m goes into 24. So if this number ever doesn't go into here, you probably did something wrong, or I chose a bad problem. It should keep going in there until the very end. But 4 times 6 is going to give me 24. M times m will give me m squared. So multiplying backwards, I'm going to get 24m squared. That would be plus 6m. Subtract. This will go away. I got to be careful here because I have a negative 14 take away a positive 6, which is really a negative 20m. And I need to slide that negative 6 down. And 4 goes into negative 20 negative 5 times. Multiply the top times over here. And I get negative 20m minus 5. Again, subtract. These cancel. I got to be careful now because I have a negative 6 take away a negative 5, which is really plus. So I now have a remainder of a negative 1. So how you deal with the remainder is you just, since it's negative, you just put a minus, and then you put that 1 on top of the divisor here. So this will be your final answer. All that good stuff using long division. Now you'll see that the next problem, I'm going to use synthetic division way faster. So I very much prefer synthetic division. And because this coefficient in front of x is a 1, I can use synthetic division. So if x minus 1 is what we're dividing by, I'm going to use x equals 1 for synthetic division because it's a 0. So for synthetic division, I put my 1 over here in a box. And then I bring down all the coefficients. 1, negative 4, 11, negative 13, 6. And I got to be careful because if I'm missing one of my powers, I need to put a 0 there. But these are all accounted for. And then here's how the game is played. You're going to bring the 1 down. And then we go 1 times 1 is 1. Add them up. 1 times a negative 3 is a negative 3. Add them up. 1 times 8 is 8. Add them up. 1 times negative 5 is negative 5. Add them up. And that is my remainder. Now, you always have to remember, if you started with an x to the 4th, you're going to be 1 power less than that. So my answer is going to be 1x to the 3rd minus 3x squared plus 8x minus 5. And then the remainder is a positive, so I'm going to go plus 1 over what I divided by. And there is the final answer. All right, moving right along, number 7. Which of the following is not a factor of that thing right there? Well, since I could do synthetic division, so if you wanted to, you could go through all of these answers, use negative 1, use 2, use 3, use negative 4, and you could use synthetic division, and if you're not a factor, that means you're going to have a remainder. So one of those numbers would give you a remainder. The others would give you a remainder of 0, so they would be factors. I think the easiest way, though, is to graph this. So let's use Desmos. So let me see if I can do this. Kind of bring this window up and shrink it down a little bit so we can see our original problem. And let's pop in Desmos here. We want the graphing calculator. All right, so we're going to type in y equals x to the 3rd minus x squared minus 14x plus 24. And look at those zeros. We have 1 at negative 4. We have 1 at 2, or at negative 2. And we have 1 at 2 and 3. So we have zeros at all those spots. So when I'm looking over here, because negative 4 is 0, because negative 4 is a 0, then this is good. Because 3 is here, this is good. Because 2 is here, this is good. So those are all factors. So what we were wanting to know is who is not a factor. X plus 1 is not a factor because it would cross the graph right there at x equals negative 1, and it doesn't. So the correct answer there is A. All right, let's go on down to number 8. Factor the expression completely. Well, first thing I would always want to try to do is pull out a greatest common factor. I don't think I can. So whenever there's 4 terms, I try to use grouping. See if I can pull a greatest common factor out of each separate group. And I think I can. I think I can pull a 3x squared out of this parenthesis, which would leave me 5x plus 2. And then I think I can pull a 7 out of the next group, which would leave me 5x plus 2. And that's exactly what you want to have happen with factor by grouping, because I have this common term now, this common factor in both those pieces. So what I'm going to do is I'm going to pull out that. I'm going to yank that 5x plus 2 out of that expression above, and what's left over is 3x squared plus 7. And then I could always check my work. I could always go back and I could multiply and actually FOIL it out, and it will come back to be this right here. So right there is factored completely, can't do any more. All right, number 9. Number 9 says, I have, looks like this is the difference of cubes. So if you look back in your notes, it might have been like 6-4 or something. The difference of cubes, meaning I'm subtracting two perfect cubes. And for instance, like I know that 5 to the third is 125. And I know that 4 to the third is 64. So I know those numbers are cubes. And I know that, m to the third is also m to the third. So those are all cubes. And the pattern for the difference of cubes were, if you could find out what a minus b is, you're then going to have a squared plus a times b plus b squared. So kind of what I'm doing here is I need to find my a and the b, and I need to rewrite it as a cube. So I think if I rewrite this as a cube, it would be 5m, all right? 5m to the third power. And then I'm going to do the next piece. Well, the next piece is basically going to be, so then I have minus. And then I could write this other one here as 4 to the third power. So if we're talking about a and b here, I now have it kind of written in the form where a is 5m and b is a positive 4. So that's my a minus b. So I'm just going to plug it in here. So a is 5m, b is 4. Well, a squared, 5m times itself is 25m squared. A times b, well, 5 times 4, that's 20 m's. And then the b squared, 4 times 4, is going to be 16. So this would be my factor completely difference of two cubes. Number 10, write the function in standard form. So I have to kind of know some things, and this is the big idea from this part. If you have a 0 that you just cross through, you just cut through it, that means it has a multiplicity of 1, which basically means that factor happens once. So since the 0 is negative 2, I have a factor of x plus 2. Well, over here, I see that it bounces, all right? So over here was multiplicity of 1. So I have a 0 of 4 that has a multiplicity of 2. Actually, it could be any even number, but it's since I kind of see the general form of this thing, I know that this thing looks like an x to the third because it goes up, it comes down, it goes up. So you need to recognize the parent function is x to the third. So I know since we've already got 1, 0 over here, there's only 2 left. And whenever it bounces, I know I'm going to have 2 factors here at x minus 4 because the 0 is positive 4. So I'm going to have 2 of those. So whenever you bounce, you have 2 of those. It wasn't really on this test, but if it comes up and it kind of bends, then you could have 3 or 5. You could have like 3 of the same root. We kind of say when it kisses like this, you have a double root there. So now that I have 1, 2, 3 factors, I can multiply them out. So let me multiply these out, give myself a little bit of room here. So I have a factor of x plus 2 x minus 4, and another x minus 4. So I can pick any two I want. I'm going to choose to do these two. Be careful you do that right. A lot of people miss this middle term, this negative 8x, but it's there. If you take your time, you draw the arrows through. And then I got to multiply by x plus 2. So I'm going to distribute the x first. I'll get x to the third minus 8x squared plus 16x. Now I'm going to distribute the 2 through. I get a positive 2x squared, a negative 16x, and a positive 32. Gather those two rows up. My new function, x to the third minus 6x squared. X's disappear, plus 32. So here's a function that is going to look like that picture up above. But I think the big key right here was understanding the double root when it bounces, when it hits and gets denied at the x-axis. All right, number 11, find all the roots for the one below. You could graph this one. That might have been an easy way. And you could see all the zeros. Remember, roots are just zeros. They're just x-intercepts. I'm going to factor this one, though, because I see this pattern to the fourth squared and then x to the 0. And you can treat this the exact same as this, which if I wanted to factor this, just good old quadratic factoring, I'd be like, well, negative 9, negative 4. Like that's the combination that multiplies to make 36 and adds to make negative 13. However, to get it to be in this 4, 2, 0 format, I just got to put a 2 here. So now it's perfectly matched up with the given equation. It's going to come out right. It's going to have x to the fourth, x squareds, and numbers, and that's it. So now I need to solve this. Well, x squared minus 9, that's the difference of squares. That can be factored down. And x squared minus 4 is the difference of two squares and can be factored down. So here are all my zeros. Negative 3, positive 3, negative 2, and positive 2. If you were to graph it, you would also see a W-type pattern that crosses at every one of these spots. So some of you may have just chose to graph it that way. All right. That's the end of part 1. We're going to move on to part 2. So let's go to part 2, pick up here with number 12. Find all the roots of the equation below. I'm going to do this one the exact same as the last one I just did because you couldn't graph this one. These were nasty roots. I'll show you what I mean. If I factor this thing, if I just ignored the powers for a second, it would be a x plus 9 and an x minus 2. And if I put the little squareds in, I'm kind of good to go. So I need to figure out when is this 0. So let me solve these separately. Well, when is x squared plus 9 equal to 0? Well, if I minus 9 to both sides, I get that. If I take the square root of both sides, and whenever you take the square root, you get plus or minus, and then the square root of negative 9 is 3i. You got to use that I because there's a negative under the radical, and the square root of 9 is just 3. Now, if I solve this one, when is x squared minus 2 equals 0? It's not too bad because the 2 jumps over here and it's positive. So now when I take the square root of both sides, I get x equals plus or minus, because square root always gives me 2 choices, and I just leave it at square root of 2. So there's my 4 roots. I have 2 of these roots over here are complex. They involve an imaginary number. Then I have 2 roots over here that are irrational. And unfortunately, you wouldn't see these on the graph. Like they cross, you know, it looks like it only crosses twice, and it wouldn't be at a nice integer number. So it'd be kind of tough. All right, find all the roots of the equation below. I guess you could graph this one. I'm going to set it equal to 0. So that'll be my first move. And then I have two options. You know, I could either go the P over Q route and find all the factors of negative 12, try them until I get one to go in, or I could graph it. And since I've already put you through the ringer before with P over Q, we're going to graph this one. So I'm going to come down. I'm going to bring up my chart right here. And let's just tweak this a little bit. X to the third minus 3x squared. This is a plus 4. And this should be a minus 12. All right. Well, what do we have here? Oh, that should be minus 4, not 44. All right. Well, what do we have? Awesome. Looks like we have a nice 0 crossing perfectly at 3. All right. That's very helpful. So I have my first 0. First of all, you need to know how many roots you're looking for. So this right here, because it's a fundamental theorem of algebra, says that I'm looking for 3 zeros. Now, luckily, from my graph, I got the first answer. X equals 3. So I'm going to use that 0, and I'm going to do synthetic division. And I'm going to hope to whittle this down to a quadratic where I have other ways to solve. So when I whittle this thing down, 1 comes down, 3 times 1 is 3, add them up. 3 times 0 is 0, add them up. 3 times 4 is 12, add them up. Awesome. I knew it was going to go in there evenly because it was a 0. But what it did was it provided me with a new quadratic that I can now solve to get the other 2. And looks like when I solve this, and I take the square root, I'm going to get x equals plus or minus. That's going to be 2i. So those are my other 2 roots, 2i and negative 2i. All right, moving on down to moving up to number 14. Write the polynomial function that has the given zeros. So the big thing you need to understand here is, you know, they give me 1 0, so that gives me a factor, x plus 3. Well, then they give me another 0, but I know that complex zeros come in conjugate pairs. So I know that I have the x minus 4i they give me, because I just put x minus in front of whatever you give me. But then I got to have the other partner too. So I got to have the x plus 4i, because always irrationals and complexes come in conjugate pairs. So I'm going to multiply this out. I'm going to specifically choose these two because there's some canceling that happens. So I get x squared minus 4ix plus 4ix cancels out. So that's gone. And then I'm going to have minus 16i squared times the x plus 3. Well, remember, I squared can be substituted. I squared is just equal to negative 1. So we can replace this I squared with a negative 1, which is going to give me x squared plus 16. And then we have this x plus 3. And now I'm just going to multiply it out. So I'm going to just kind of use my distribution. Distribute the x. Distribute the 3. And group everything together. I'm going to put it in descending order. It's kind of a good habit to get into. And boom, there is a function that is going to have the zeros. So if you know zeros, you can use factors and work backwards. If you get the equation, you want to find factors to get zeros. So it's kind of a two-way process. Number 15, this is just more kind of a conceptual question. There's really not a lot of math to do. But think about a graph. Think about your xy axis. And as x goes to the right, so as x gets bigger and bigger and bigger, y goes down. So I know my end behavior is doing like this. And as x goes to the left, negative infinity, y goes up. All right? So there's something like that going on, and I know that it goes in opposite directions when you are an odd function. So something like x to the third, x to the fifth. But I know like with y equals x to the third, you know, that one starts low and finishes high. Well, this is inverted from that. So I know that there's got to be a negative coefficient in front. So I know this function is odd, but it's got a negative lead. So the correct answer here is going to be B. Number 16, what is the degree of the simplest polynomial with that stuff? So again, kind of more a conceptual question. If you have radical 2, that automatically means you're going to have negative radical 2 because they come in pairs. If you have 2, you don't know anything. You're just given the 2. There's no pairs with the rational numbers. And then if you have a 3 minus I, you're also going to have a 3 plus I. So actually there's 1, 2, 3, 4, 5 zeros going on there. So it's going to be a degree 5. Number 17, you have the box constructed out of, metal, and you have an 18 by 24 piece. We are trying to cut out the corners. We don't know how many feet, but we're cutting out an x by x square out of every piece. And then we're going to fold it up, and we're going to have like a three-dimensional box that's going to look something like so. And we want to find the volume of the box. Well, once we cut the x off, our dimensions, this piece right here, that's going to be 24 minus the 2x. That's our length. And then over here, our width of that box, well, that's going to be 18 minus 2x. And then when you fold it up, these little pieces here are going to fold up. They're actually worth x, so that's the height. So I now could write a formula for this box that the volume is the length times the width times the height. All right, length times width times height. Now, I want to find out the amount that should be cut off for each square that's going to maximize that volume. Now, let's just think about some constraints, some restrictions on x. I have to cut off something, so I know that x has to be greater than 0. But there's a limit as to how big it could be, because if x ends up being 9, if I cut 9 off of this side and 9 off of this side, I don't have a box left. So I think our x's on our graph, we only need to be concerned with what happens between 0 and 9. So I'm going to go ahead and I'm going to graph that function. So let's kind of pull up the old graphing calculator again. I'll move this over some. And you see we had parenthesis 24 minus 2x parenthesis. Then we had 18 minus 2x parenthesis times x. And this was supposed to be y equals, there we go. And let's just see what that looks like. So I'm only concerned about between 0 and 9. Well, right now I'm having trouble finding a maximum because it's going way up there. So let me kind of move this over and see if we can play with the axes. And I only care about 0 to 9. Now you guys on your TI, you could click calculate maximum and find it. I know it's up there quite a ways, so I'm going to just go from like 0 to 1,000. And boom, I find it. So way up here in the 600s. Desmos is nice because you can just kind of click on it and it will give you the amount. So let me kind of slide this over So this amount, if you notice the x number, so when I pull up the x number, x is going to be 3.4 feet. So that means I'm going to cut off 3.4 feet out of these corners. All right. And then when I do that, you know, if I were to put 3.4 in for these x's up here, I should get this number, which is my volume number. So my volume, my max volume is actually going to be 654.977. And you could round somewhere like that. Volume is in cubic feet, and my cuts are just in normal feet. I know some people found the area of the square, so maybe the way I worded it was a little bit misleading. So I guess if you did 3.4 squared, that would give you the area of each of these little squares. But wasn't what I intended, but maybe it wasn't super clear, so my bad on that. All right, let's keep going. Oh, I think I got rid of the wrong thing. All right, so that was that one. Let's keep going down here to find the local max and min. So again, you could use your TI and use the calc feature. I am going to use Desmos because it's faster for me. And I could show you in class if you need for me to do it in class. But, so let's restart this over. Y, let's raise it up a little bit, equals negative x to the third power plus x squared plus 2x. Now my window's probably really goofy. Like I'm not seeing a whole lot here because my y's are like crazy. So let's try to get a better window here. And I basically got to zoom in and see what's going on from like -3 to 3. So let's see what I can find there. -3 to 3 on the x's, and my y's, I don't know. Let's go from -3 to 3 on this one. So, and let's just see what we got going on. Oh, there we go. That gives me a nice little picture. So my bottom is right here. So there's my local min. Get my cursor just right there. So as far as the minimum, the local minimum is occurring right there at -0.549 and at a y value of -0.631. And then my local max, my local high point, is going to be right over here. And so I'm going to put my cursor over there. And unfortunately, I got to clear it out for it to show. But there is my max, and that's going to occur at 1.215, 2.113. All right. So you're just trying to find the local top and the local bottom. If you need help with your TI, just let me know. I will help you with that. Number 19. I like this problem. This is kind of a challenge type question. It says, if there is a remainder of 11, so that's my clue, and you divide that function by x minus 2, well, because there's a 1 here, I know I can do synthetic division, and I know if it's x minus 2, I'm going to use x equals 2 for my division. So I'm going to use x equals 2, and I know the function is 1, -3, h, 5, and 1. And then my other last clue is I know the remainder is 11. So I got to kind of fill in the missing puzzle pieces to figure out what the heck this h is. So let's start working on it. Well, I bring the 1 down. 2 times 1 is 2. Add them up. 2 times negative 1 is negative 2. Add them up, but I can't. I don't know what h is. So I'm going to freeze there, and I'm going to start working from the back side. If the remainder was 11, and I added them up, that must have been a 10. Well, how did I get the 10? It's going to be 2 times 5 would give me that 10. Well, then how did I get the 5? I must have added 5 plus 0 to get that 5. Well, then how did I get that 0? There must have been a 0 here. Well, then h something plus a negative 2 give me 0. The only thing that could be is h has to be 2. So the correct answer here is D. Kind of like that problem with synthetic division. And then lastly, company sells 40 tennis shoes per week at a price of $90. So if we look at our equations here, revenue would be the number of shoes you sell times how much the shoes are. So it looks like, this is my $90, and it says it's been projected that every time I decrease by $2, so every time I decrease the price by $2, what happens is I sell an increase of 5 pairs of shoes. So I normally sell 40, but I can increase it 40 increased by 5. So X is actually, if you look at what X is, X represents the price reductions. So let me just kind of show you. When X equals 1, what I'm doing is I'm reducing the price from 90, take away $2. So it'd be $88. But I would sell 45 pairs of shoes. So if I multiplied those two together, and I wanted to figure out, what my revenue is, and I'm like, all right, 88 times 45, and I'd be like, sweet, it's $3,960 that week. Well, let's say I did a second price reduction. So I reduced it 2 and then another 2. So that would be a reduction of $4. I now have an $86 pair, but I would sell an extra 5 pairs that week. So 86 times 50. Ooh, that's even better. Now I'm up to $4,300. And I'm going to keep on going. You remember at 0, at the current model, $90 pair of shoes, I sold 40, $3,600. So it's in my best interest to keep lowering the price of shoes. The problem is you're going to get to a point where you reduce the price so far that you then start making less money. So it's going to form, because I have an X and an X, there's going to be a quadratic going on here. All right? So let's try to kind of calculate this thing out, and let's get our quadratic and figure out where our maximum is. And remember, X is the price reductions, Y is the revenue. So let me pull up Desmos, our good old friend. I'm going to put it over here on the left this time. So my equation is going to be parenthesis 90 minus 2x parenthesis. Actually, I think I need to just get rid of this. Start over. 90 minus 2x. And then I'm going to have a 40 plus 5x. And what I want to do is, I'm trying to figure out where the maximum is. Well, here's my parabola, but it's way up there. Like I'm moving it down. I need to definitely change my x's. So I'm going to go from, I'm not having negative price reduction, so I'm going to go from 0 to, let's say, 50 on my x's. So let's go 0 to 50. And my y's, I don't know. We were climbing quick. We were at like 3,600, and then we were quickly up over $4,000. So I'm going to go $0 up to, I don't know, maybe $10,000. And there we go. So now I should be able to see a maximum. And right there is the maximum. So let's kind of interpret what that really means with this problem. So I come through here. I found this maximum way up here at the top of the quadratic. And it's telling me that when x is 18.5, my y, or my r of x, my revenue, is 7022.5. So I think I found the max revenue. It's $7,022.50. That's the most money I'm going to make. But the other question says, what should be the price of shoes? Well, it's not $18.50 because X didn't represent the price of shoes. X was the number of reductions. So remember, this is the price part. That was the price of the shoes. So if I do 90 minus 2 times 18.5, put X in there, that's 90 minus 37. That would mean a $53 pair of shoes is going to give me the very best, highest price possible. You know, if I start dropping the shoes too much and I drop them way down, then my revenue is going to start falling. So it kind of comes to a point where you're like, it's going good, it's going good, it's going good. Oh, don't stop dropping the price stop dropping the price because you're going to lose money. All right, I believe that's it. Hopefully that helps explain the test for you. And if you're in need of a retake, it'll get you squared away for the retake. See you.